record. Okay. Here, management of packet loss. Delay and jitter. Okay, first thing. Okay. And here, what we have to do, we need to reduce the packet loss, latency, and jitter. And also we have to set the priorities for certain type of a data. Setting priorities for specific types of data. Okay. Okay. And also we need to prioritize the traffic. That the more important traffic should pass first. Prioritizing the data, prioritize data that more important traffic pass first. Pass first. Okay. So these are certain things quality of services assist with. Okay. So here in quality of service, what happens? No, a management of packet loss. We have to manage the packet loss. We have to make sure that the packet loss should be minimum. And also the delay. What do you mean by delay? Delay means the total time to reach the destination. For example, this is the source, this is the destination. The delay nothing but it calculates the time taken by a packet to reach its destination will be called as a delay. And also we have a jitter. Jitter means what? The delay might be some time. For example, the packet to reach its destination from source to destination takes 1 millisecond. Okay, sometime it will be 2 millisecond. Depends upon the traffic. This time taken by the packet will vary. That variation in the time will be called as a jitter. Clear? The variation in the time will be called as a jitter. So we have to manage the packet loss, the delay, and the jitter. Means all these things must be as minimum as possible. We must keep all these things as minimum as possible. Okay, there should not be any packet loss, latency, and jitter. And also what we have to do here to ensure the quality of services, priorities for specific types of data, we have to set the priorities. For example, in the road also, what we will do generally, if there is a ambulance trying to cross the road, what happens? Public will make a way for an ambulance first. Why? It's a more important than normal traffic, right? And also the traffic signal will also be turned green to make a way for ambulance. Similarly, when there is a VVIP guest or prime minister, chief minister and all, they pass by the roads. No, there are also certain protocols. The traffic police will help them to pass first. Okay, so this is the way how we deal with the important person. In the similar fashion, in when it comes to the data also, no, in data also there are certain types of data which are very sensitive to jitter and all, latency, jitter and all. So what we have to do here also, we need to set the priorities for such data. For example, what are the different data types when it comes to the network? We have a data such as we can send the data like voice, okay, and there is a video, and we have a normal data, okay, that is transmitted through the network, okay, like email and all. So voice, okay, just say like IP telephony, voice over IP, Vivo IP data, it is considered to be very sensitive data. They are very sensitive, they get disturbed soon. So this data needs to be taken care first. This has to be set the first priority. Okay, then comes the video. Okay, if the video, if bandwidth is less, if there is a traffic, then what happens? No, we will start feeling the buffering, the lags, okay, and all. You sometimes You might have seen all this in YouTube while playing the YouTube. Clear? Video is also next sensitive. The first sensitive data is a voice. The next sensitive data is the video. Then comes the data. Because now these voice and video uses a UDP protocol, user datagram protocol. This user datagram protocol used for a real-time transactions. Whatever the transaction is happening right now, no, those data needs to be sent at the same time. Okay, we don't have a time. For example, this regular data, to send the regular data, we use a protocol called TCP. In TCP, what happens? So we have a sufficient time. In TCP protocol, this is considered to be the reliable. UDP considered to be the unreliable. Unreliable, nothing but it delivers the packet as earliest as possible. Whereas in TCP, what happens? Reliability is given the preference. Reliability is the preference. For example, now from here, source, this is a destination computer. In TCP kind of a transaction, whatever, once the data reach its destination, no, this is the data. Once the data reach its destination, this is a source computer, this is a destination computer. What happens? The destination computer will going to send back an acknowledgement. Okay, I received your data. Okay, for example, it sent 10 packets at a time. There are packets, yeah, in 10 in numbers. Okay, it receives acknowledgement for 9 packets. Then one packet is left out. Then what happens? No, this source will going to wait for random amount of time. The same data will be retransmitted to the destination. This is how the TCP connection is going to work. This is why it is called as a reliable. Reliable means there is no packet loss. If there is a loss happens, then also no, the source will make sure the data which stuck or which is not able to reach the destination will be retransmitted. But there is no such thing when it comes to the UDP. Why? There needs to be real-time transaction needs to be takes place. Whatever the thing is happening right now, no, that data needs to be delivered. Okay, if certain packets are dropped, okay, that can't be retransmitted in case of a UDP. This is the differences. So we have to give the priority first to voice video, then comes the data. This is how we have to prioritize. Then what are the factors which affect the quality of services? Okay, then the factors which affects the quality of services, like there are factors which affect quality of service, QoS. Okay, certain factors such as a bandwidth. Okay, bandwidth is also one of the influencing factor. Okay, bandwidth means what? Bandwidth generally is the speed of a link. Speed of a link or interface. Okay, that is generally measured in bits per second. Okay, like we have a 10 bits per second. Okay, and also you can also think like this. The bandwidth also can be considered as a capacity of the link. The data, the amount of data is a cable, is a link is able to carry at the same time per second. That's what we call as a bandwidth. Okay, and this bandwidth is also one of the most influential factor when it comes to the quality of services. Less the bandwidth, then more the congestion. The next factor is the congestion. Here, okay, what is congestion? Congestion means the congestion, due to the congestion, it causes the delay or latency. Okay, means here when congestion happens, when we present more traffic than it can handle. When we present more traffic, than it can handle. Okay, for example, here I'm having a link. This is a switch. Okay, and this is connected to, this is outgoing interface, this is the incoming interface. Here this incoming interface is of a 1000 Mbps, the outgoing interface is of a 100 Mbps. Okay, then what happens? Now automatically this entire throughput, this could not able to handle. 1000 Mbps is incoming, outgoing is 100 Mbps. This is a speed mismatch is happening here. Then what happens? Here also congestion is going to happen. Clear? Then there are so many such examples. In short, no, when we put more data, when we present more data, then a link can handle, no, then congestion will take place. Okay, congestion. The next, delay. We have a delay. Delay means, as I told earlier, no, delay means the time taken by the packets to reach source to destination. Time it takes per packet to travel source to the destination. Source to the destination. Okay. This is what we call as a delay. This is also one of the major affecting factor when it comes to the delay. Then jitter. What is jitter? Jitter means variation in the delay of received packet. It's a variation in the delay of received packets. Okay. Clear the variation here. To travel from source to destination, this is my path, this is my road. Sometimes it takes 1 millisecond, sometimes it might take half millisecond. Okay, 1/3 millisecond, sometimes 2 millisecond. Okay, this jitter will vary. Okay, based on the real traffic conditions. This is what we call as a delay. This is what we call as a jitter. Okay, in order to make sure the quality of service, what we have to do, we have to make these jitter as much as minimum, means we have to make it stable. There should not be more difference like 1 millisecond, half millisecond. It should be transmit the data in a scheduled time. For example, it should not cross more than 1 millisecond. Okay, 1 micro millisecond might be okay. It should not be differ much. That needs to be taken care. Okay, so quality of services tools. We have certain tools. Just push this up. Quality of service tools. Like we have a tool such as classification and marking tools. Classification and marking tools. Okay, so that we have to classify what kind of data it is. Okay, so that we can mark that particular type of a data. We can classify, we can mark. Then comes the congestion avoidance tools. Congestion avoidance tools. Then we have congestion management tools. We have a congestion management tools. Okay, first what we have to make, we have to make the classification, what kind of a data it is. Okay, whether data is belongs to the voice, or data is belongs to the video, or data is belongs to the, this is a data which is related to the voice. It's more sensitive, so that it should pass first. Then comes the data which is related to the voice. Then comes the data which is related to the text and all, like email, etc. Okay, we have to do the classification like this. Then comes, once the classification is done, marking is done. Okay, this is a marking. Okay, once the marking is done, what we have to do? We have to use the congestion avoidance tool by setting up the policies. Okay, in next phase, what we have to do? We have to set the, we have to do the policing and selective dropping. Policing and selective dropping. Okay, policy and say selective dropping means, here what happens? No, we have to set the policy like if data exceed more than 1 Mbps, or if packet flow is greater than this amount of packets, if you receive, okay, allow this much of these many packets at once. If it exceeds, then drop other packets, like this. We have to set the policies. Then also in the congestion management, what we have to do? We have to set up the queuing, scheduling and shaping. Scheduling and shaping. Queuing, scheduling and shaping. In queuing, what happens now? If the data is able to carry 100 Mbps of the time, what we have to do? Next, the data is, if the data is coming at the speed of 150 Mbps, the rest 50 Mbps data needs to be wait in the queue. It's in the buffer. Okay, let's queuing. And also we have to schedule and shaping. Scheduling means once this data cross, no, then we can allow other packets to cross the data. We can schedule, and we also shape. Okay, at what speed, what is the maximum bandwidth a data interface can utilize, make use of it. That's what we call it as a shaping. Classification and congestion avoidance tools by setting up the policies, and selective dropping and the congestion by queuing, by sending the data which needs to cross the cable, wait in the buffer memory, and we can schedule when the data needs to be crossed, and the shaping, what bandwidth it can use. So these are the things we have to do. Okay, these are what we have called as a congestion avoidance. We can set the threshold. Now, what we will do when it comes to the queue, now there is a technique called a FIFO. FIFO means first in, first out. This is one of the method. Okay, where comes the first? Okay, they will we will set the priority for him. Okay, he will exit first. First in, first out. This is one of the example for queuing. And also we can set weighted queuing. In this, what we can do, we can schedule weighted queuing. WFQ. Okay, in weighted queuing, what happens now? It is like automated scheduling method that provides fair bandwidth allocation to all traffic. Okay, weighted queuing, what happens now? It will allocate the equal bandwidth for all kind of a traffic. This is also one of the method for a queuing. And also we have a one more technology called CBWFQ. In this, what happens? Class-based weighted fair queuing. In class-based weighted, let me write here, class-based weighted fair queuing. Okay, this is one of the technology. In this class-based weighted fair queuing, what happens? No, this is just extended feature of WFQ, weighted fair queuing. In this, what happens now? It provides support for user-defined traffic class. Okay, we will be having a different kind of a traffic, no? Okay, so based on that, here we can set the priority to certain types of data when it comes to CB class-based weighted fair queuing. So these are the some of the terms when it comes to the quality of services. Then we will proceed towards the practical now. We will set policing We'll set the shaping as well. How we can set the policy, how we can set the shaping when it comes to a network, we will see practically. Okay. For that, I am going to make use of my GNS3 tool. Here I just push all this content upwards. Then I will go to the GNS3 tool. Okay. Here I'm going to open SAPA lab quality of service QoS. Okay. Here I'm having a small lab. Okay. This is a small topology. I'm having two routers and there are two client computers. Both are Windows 7 only. Let me consider this side of a device as a client, this side of a device as a server. Okay. In this lab, what we are going to do, we are going to shaping the policy. Shaping means here, first, let me analyze and let me check what is the speed I am going to get between these two devices first, end to end. How much bandwidth they are going to get from while sending and receiving the data from here to here. Total bandwidth I will check first. Then next step onwards, what we are going to set up the policy. We are going to set up a shaping. In shaping, what happens? No, this router one should not use bandwidth of more than 1 Mbps or 10 Mbps. Like this, we are going to create a policy. We are going to create a shaping lab and we are going to set that policy, or we are going to set that policy in router one now first. Okay. Means shaping means what happens? The data, we can control a bandwidth. It should not exceed, the bandwidth should not exceed more than 10 Mbps. Likewise, no, whenever we take an internet connection, what they will do, internet service provider, ISP, what they will do, they are also going to set as the internet connection speed and along with the price tag. For example, if we are going for a 100 Mbps link, no, they might charge us uh, $50. Okay. When it comes to the India, no, it in 1,000 rupees. Okay. If it's a 150 Mbps unlimited, then they will use 1,500 rupees. Okay. I don't know about US, but in India, no, this differs. Okay. Like this, when they set this amount of bandwidth, no, actually ISP side, what they are going to do, they are actually setting up the policy and shaping. The data should only make use of this amount of a bandwidth. Okay, the link only make use of this amount of bandwidth. So this is how they are going to set that quality of service. This is how they are going to allocate us the bandwidth. In a similar fashion, here also I am going to set a shaping lab. First, in shaping lab, we are going to set certain policies. We are going to create certain policies under router one, and those policies we are going to set on these interfaces. Okay. There are two interfaces. Either I can set the policy on Ethernet 0/0 as an inbound or Ethernet 0/1 as an outbound. It's up to us. But before that, let me turn on these devices first, and also let me check the memory allocation. It requires this policy. This lab requires more memory. Okay, 512 MB is the RAM size and 128 kilobytes is the NVRAM. Okay, that's enough. Then I'll configure. Here also, I'm having the same. Okay, then I will turn on these devices first. Quickly, if you click here, all the devices will turn on at once. Then if you click this console connection, what happens to this? This is unable to start. I'll turn this off. Stop. I will do one thing. I'll delete these two routers here. Instead of these two routers, I'm going to pick up fresh routers. Okay. Now I'll connect all of them together. Okay. First I'll configure the memory. Configure. Instead of 250 Mbps, I'll use Pytel. NVRAM 128 kilobyte. Apply. Okay. Same here. Configure. Pytel 128. Apply. Okay. Okay, both have turned on. Meanwhile, I'll try to use this Windows 7 computers. Okay, they are also turned on successfully. This is a Windows 7 client. This is a server. Just I will log in. 123 is the password here. Test 123 is the password here as well. Okay, they're logged in successfully. No problem at all. Okay. Just turn this in the corner. Router 1, router 2. Okay. First of all, what I'll do, Udit, here, I'm going to set the IP addresses as per my intended plan. This entire thing belongs to the 192.168.10.0. Here I will set 192.168.10.1 IP address on this interface. Okay. Similarly, 192.168.12.1 is the IP address on Ethernet 0/1 interface. Here 12.2, 11.1. Here on my device 11.10. These are the IP addresses. This is my intended plan. Now, first I'll go to the global configuration mode. Under the global configuration mode, interface Ethernet 0/0 IP address 192.168.10.1 255.255.255.0. Then type no shut exit. Then go to the interface Ethernet 0/1. Then type IP address 192.168.12.1 255.255.255.0. Then type no shut exit. Show IP interface brief 192.168.10.1 12.1. Okay, I set the IP address. Then I'll go to the router 2. Then the global configuration mode, interface Ethernet 0/1. Then the IP address would be 192.168.12.2 255.255.255.0. No shut exit interface Ethernet 0/0. Then IP address would be 192.168.11.1 255.255.255.0. Then type no shut. Okay, this is the basic configuration. Just I have not done anything except setting up the IP addresses on the interfaces. Okay, next thing what we'll do here. Okay, after that I'll just check the connectivity between these two routers first. Do ping 192.168.12.1. Okay, fine. Okay, I'm able to get the response. So it is working fine. The next, I'll check the connectivity from client to these routers. But before that, let me set up a static route first. From router 1 perspective, for router 1 to reach this 11.0 network, no, this is the next hop IP address. 12.2 is the next hop IP address. Okay, I will make a static route now. How to configure static route? Very simple. IP route. I'm going to form a route to 192.168.11.0 network. The subnet mask of that particular network is 255.255.255.0. 192.168.12.2 is the next hop IP address. Okay. If you want to reach this 11.0 network, deliver those packet to 12.2. This device, this interface will going to do the rest. Okay, that's it. Enter. In a similar fashion, router 2 also I have to do the same. IP route 192. This router does not know about this particular network 10.0. So that here I'm going to form a static route 192.168.10. 255.255.255.0, 192.168.12.1 is the next hop IP address, forwarding router's IP address. Here also I've done the same. That's it. The next phase, I'll use this virtual machines here, my VPCs. Screen resolution, I'm going to increase a bit, 1024 by 768, so that the display will be bit bigger. Okay. And I'm having two different machines. I'll just go to personalize. I will change the background of one of this. Okay, so that by looking at the device itself, we can able to see. Okay. This is my client machine. This is my server machine. Okay. So here, what I'll do, what is the IP address of this client and server? Let me check first. Okay, just make it bigger. Now, if you type IP config, you're going to see the IP address 192.168.10.10 is the IP address here. Similarly, I will go to my server machine. Here also, I'm just going to set the properties, font. Okay. So IP config 192.168.11.1 is the IP address of this local machine. Let me ping from here to here. If I ping 192.168.10.1 from here, ping 192.168.10.1. Okay. See, the reply is coming from this client computer. Okay. So what does it mean? It means that we have a connectivity. We have a connectivity end to end. The client is able to connect to the server and vice versa. Okay. So we have a end to end connectivity. Then next phase, what I'll do, I'm going to get the total bandwidth. How much bandwidth they are going to utilize now? How much bandwidth is there between this entire link? How much bandwidth they are going to get? They are going to utilize now. So to check that bandwidth information, here I'm having a software which is already I have downloaded in my local computer. Okay, IPERF, Internet Performance. View medium icons. Okay, you can see this IPERF. This is a piece of software that helps us to view the bandwidth from source to destination. Okay, you can download it free of cost. IPERF download. If you click on the Google IPERF, you can easily download this software. I have already downloaded and kept on my desktop itself. Okay, I am going to make use of this software to analyze the bandwidth. For that, what I have to do, I need to go to the my command prompt once again. In the command prompt, I have to access the desktop first. Directory. Okay, here I'm having a folder called desktop. To go inside the desktop, in the command prompt, type cd desktop. Okay, right now I'm inside the desktop. Again, type the directory. Here there is a folder called IPERF. Okay, so cd IPERF. Okay, I'm inside the IPERF folder. The next phase, what I have to do, I have to set, I have to execute. I'll go to the server first here. Okay, in the server, this is my server machine. That I will also going to do the same. Type cd desktop. Under cd desktop, there is a folder called here IPERF. Okay, so cd IPRF. Okay, under that, what I have to do, I need to type a command here. What is the command? The command is IPRF3. IPRF3. See, I'll show you. Inside this folder, no, I have a file called iperformance3.exe. I have to execute this file first. Okay, IPERF3, then -s. If you click this, no, automatically this will start acting as a server. Okay, it will start listening from the client. Okay, server listening on 5201. It started listening. Same way, what I have to do here, I have to specify the same thing, IPRF3, then type -3, nothing but connect. -c matlab connect. Whom I am going to connect? Sorry, what happens to this? Okay, IPERF3 once again -c connect. I am going to connect 192.168.11.10. Means this is the IP address of this server, this computer here. Okay, I have to specify that. After that, -p. Okay, send packets 8. Okay, then enter. If you enter, no, it will send certain packets to the server, and it will going to check. It will going to analyze how many how much bandwidth it is going to utilizing. Okay, see, it connected. Okay, connected, and final bandwidth here, total bandwidth is 28.1 Mbps. How much bandwidth I am going to use here? 28.1 bandwidth. 28.1 megabytes per second is the bandwidth. Okay, this is the total bandwidth I am going to make use of. Okay, this is the bandwidth I'm getting right now. What I have to do, I have to set the policy. I have to set the shaping now. I have to set the shaping, nothing but I should not, the bandwidth should not exceed 10 Mbps. That's my goal now. Okay, so I'll go to the labs, my GNS3 lab. Under GNS3 lab, what I'll do, I'm going to set the shaping configuration. Okay, for that, I'll go inside my router 1. Minimize this. Okay, I need to go under the router 1 first. Under router 1, what I have to do? Okay, just clear screen. Okay, I need to create an access list. Type IP access list extended. Okay, type the name of that access list, IP access list extended, and type name as test. You can give any name to it. Test. Okay, IP access list. Here I am going to say that I am going to create access list. extended access list. The name of that access list will be test. Okay, press enter. After that, I need to specify the condition here. Permit whom, permit IP, host, which host I'm going to permit. I'm going to permit this host reaching this destination. Okay, permit host. Host IP address is 192.168.10.10 is the IP address of this client. Then next, host, I have to specify the destination. Okay, 192.168.11.1. Okay, permit this IP to reach that particular destination. That's it. I have created the access list. Then exit. After successful creation of the access list, we have to create a class map. Okay, class map match all. Okay, so I need to create a class nothing but it's like a classification class map match all nothing but match all the packets, and I have to specify name C map. You can set any name here. Class map name is C map. After the class map, we have to call this access list, and we need to enter here match access group name. What is the name of my access list? The name is test. That it needs to be specified here. Then after the class map, we need to exit. We need to create a policy map. We need to set a policy map. Policy map. Policy map. Okay, under policy map, we have to set a policy here. Policy map, we have to type a name for policy map as P map, policy map. Enter. Then we need to call a class map here. Class map name is C map. Okay, class map name under policy map. Here I am going to use this class map to set the policy C map. Okay, then next here type shape. Okay, shape. Then if you put question mark average, type average, then shape average. Then if you put question mark again, you have to specify the bandwidth. What is the bandwidth? 10 Mbps, 10 em. Okay, average, I should get the total 10 Mbps bandwidth. It should not cross 10 Mbps. Clear? Enter. Shaping. This is the shaping policy. 10 Mbps. Okay, I have set the 10 Mbps. Then I exit. Creation of the policy is not enough. That policy needs to be applied. Then only it will be effective. Then only it will going to work. See, here I am going to set this policy. Where this policy can be set? Either the policy can be set on the interface Ethernet 0/0 as an inbound, or the policy can be set on the Ethernet 0/1 interface as an outbound. Okay, preferably this is the interface. It is getting connected to the ISP, so that here I am going to set the policy on Ethernet 0/1. I have created a policy. What this policy says, permit this host. Then I have created a class map called C map. Then I have created a policy map. I have that class map. I have called successfully that I have matched that test access list inside the class map. Under that class map, I have created a policy called PMAP. In that policy, I have successfully called a class map. Then in the class map itself, in the policy map itself, what I have done a shaping. Shaping nothing but I said here shape average. It should not cross the 10 megabits per second. The data should not be more than 10 Mbps. This is what the average shaping is. This is what my limitation is. This is the restrictions I put on this policy. Now this policy needs to be applied. Where we can apply? Here I am going to apply on this interface. Interface Ethernet 0/1. On this interface, I am going to apply this policy as a outbound. Okay. So to apply, there is a command service policy output. What is the policy name? PMAP. No, PMAP. Service policy output. Policy map name is PMAP. So service policy map name is PMAP. You have to enter. Okay. As soon as I enter, no, automatically the data transmit rate will be limited to 10 Mbps only. Earlier, how much we are getting earlier? Just we tested, no, 28 Mbps, right? 28.1 Mbps, the amount of bandwidth we got here. See, 28.1 Mbps is the bandwidth we got. Okay. As soon as I set the policy, now what I'll do, the policy, because of this policy, the bandwidth should not exceed more than 10 Mbps. I'll enter. I've entered this. Let's check once again now. Okay. So I'll checking one more time. A performance connect 192.168.11.10, but just enter. Let's see. Okay. See, Udit, earlier how much we are getting? 28, but now it is average 11.2 Mbps. I said 10 Mbps, sometime 1 Mbps here and there. It will, there is a fluctuation. Okay, 11.2 Mbps here I am getting. Clear? 11.2 Mbps is the bandwidth here I am getting. Earlier used to get the 28 Mbps the bandwidth, but now 11 Mbps because of the policy. See, if I remove this policy, I'll type no. Okay, I'll remove this policy. I have removed the restrictions. Then I'll check once again. What will happen now? Okay. Then once again, I'll execute this. Because now there is no policy applied, I should be able to get more bandwidth. See, now 29.6 Mbps is the bandwidth. 29.6 Mbps is the bandwidth I'm going to receive. Clear? So this is how you can shape. This is how we can shape the policy. Okay, shaping can be set. It should not exceed this bandwidth. Okay, if it started crossing this bandwidth, automatically it will start shaping it. It will compress. It will press. It will make sure the policy, the bandwidth should not exceed certain amount of level. Okay, this is the quality of service lab. This is how the quality of services can be configured. This is how shaping can be configured. I hope you understood today's topic.
Yes,
Hello?
I did.
Okay.
Yes.
Okay, fine.
Yeah.
So with this, I am going to conclude today's session, Udit. Then
Okay.
we will come up with a new session tomorrow. Okay?
Okay. Thank
Okay,
you.
good.